Okay, let's look at one more example. A child is lobbing rocks at a window 3.8 meters above the ground so that they just barely reach the window. If the child is standing 4.4 meters from the base of the window, what is the initial velocity of the rocks? Write your answer in polar component and component form. So the picture is almost the exact opposite of the one we did earlier. We know that it's 4.4 meters this way. We know that it's 3.8 meters this way. So it's going up instead of coming down. Vertically, we know that delta y is equal to 3.8 meters. We know that the initial speed we're going to call vi. Acceleration is gravity, negative 9.81 meters per second squared. And we know going up that our final speed is 0 because they just barely enter the window. In other words, it's only the horizontal velocity that remains. Now, to do this, if we start with our delta y is 1/2 at squared plus vit, like we did previously, we have two unknowns. We do not know our initial speed, we do not know our time. So that presents a problem. Instead, what we can do is we can find the initial vertical component from the algebraic combination. Vf squared minus vi squared is equal to 2a delta y. Since our Vf squared is 0, we don't know our Vi squared. Our acceleration is due to gravity. It's negative 9.81, and we go up 3.8 meters. Now be careful here. Remember, this negative is not a squared term. It's the negative on all of that. That means these two negatives will cancel out. So Vi squared is equal to about 74.556, so Vi is going to be about 8.63 meters per second. So that gives us our initial vertical component of velocity. We still don't have our time. Now we have two options here. We can go back to the definition of acceleration, or we could go back to the displacement under accelerated motion. I'm just going to go to the definition of acceleration. Acceleration is delta V over t, which is Vf minus Vi over t. Now I know my acceleration is a negative 9.81. I know my final velocity is 0 and my initial is a negative 8.63. And I know, or I don't know my time. I'm looking for my time. So time is simply going to be 0.8797 seconds. And I'm only going to carry this to 8 seconds. That's all vertically. Now that time does carry over to the horizontal motion. Horizontally, I can now go to my delta x is 1/2 at squared plus vit. My horizontal acceleration is still 0, so 4.4 meters is equal to my initial velocity times my time, which is 0.088. That gives me an initial velocity of about 5.0. In component form, that means my velocity is 5.0 I plus 8.6 J meters per second. In polar form, what I need to do is I need to find my angle and I need to find my hypotenuse, my resultant. This was 5, this is 8.6. That's R. So I use Pythagorean. To know that my R is approximately 9.9 meters per second. And then I use tangent of 8.6 divided by 5 to get about a 59.8 degree angle. Really a 60-degree angle. Use Pythagorean. Five squared plus 8.6 squared is equal to r squared. And then for my angle, I use the arctangent of 8.6 over 5.